In section 5.1 part 3, we move on to another formula, and this one's called continuous interest. So continuous interest compounding, or continuous compounding interest. Okay, so this takes the idea of compounding it daily and takes it to the extreme where you're constantly adding on that interest. Your book does derive the formula. If you want to look in section 5.1 towards the end of that section, you'll see the derivation of it. The key is that we're going to end up with this, PE to the RT, PERT. And again, E is built into your calculator. It is a constant. It's 2.718, and then it goes on. What you're going to do in order to find it is you're going to see it above the LN key. So if you look at your LN key right above it, you should see E to the X, and that's where we're going to find the E at. You should have had exposure to this formula in the 101 class or your previous algebra class. Example 6 compares a daily and a continuous, just to see what the effect is. So we're going to find the accumulated amount after 3 years. If $1,000 is invested at 6% per year, compounded, part A does daily, part B does continuously. We know that we're investing $1,000 at 6% per year, and we know that it's for 3 years. So for part A, we're going to do daily. Compounded daily goes back to the A equals P times 1 plus R over M, the MT formula. So that would be the $1,000. 0.06 divided by daily would be 365. I didn't write that down. M is 365. Raised to the 365 times the 3 years. And if we do that, we end up with $1,197 and 20 cents. So after 3 years, my $1,000 has grown to $1,197. Not bad. Okay, part B uses the word continuous. Anytime you see the word continuously, that is when you're going to use that PERT formula with the E in it. So now we'll do A equals PE to the RT. So that would be 1,000. E, again, built in on your calculator. The interest rate is still the 0.06. The time is 3, but notice there's no M, no conversion period. The E is taking care of the conversion period for us. So if you run that into your calculator, you're going to see that you get $1,197.22. So by doing it continuously, we've gained 2 cents. Not a lot, but we only invested $1,000 for 3 years. So, but that's the difference between daily and continuously. Now, when you go to the bank and you want to borrow money from the bank for maybe a car loan, or you're getting some money to buy some furniture and so forth, a lot of times they'll tell you different interest rates compounded at different amounts, so different conversion periods. So what we need is a formula that lets us compare different conversion periods. And so that's the effective rate of interest. That's the last formula to throw at you. So the effective rate of interest, R effective, is equal to 1 plus R over M, the M, and then minus 1. So again, what this does is it gives us an effective rate of interest. Again, that lets us compare rates of interest with different conversions, with different values of M. So this is the effective rate of interest. This is the given interest, and the M is still the conversion periods. So our final example, well, our next example, find the effective rate of interest corresponding to a nominal rate, and nominal means per year, of 6.5% compounded, and then annually, quarterly, and daily. Part A is annually. Okay. So this one's not going to come out to be a big surprise here. So we know that the given interest rate is 0.065, that's 6.5%, but it's a yearly rate. This is a yearly rate. So if we run it through this formula, we should get the same answer right back out of it because they're both yearly. So no surprise on our answer on this one. We'll have 1 plus 0.065 divided by 1, that's our M, to the 1 minus 1. And again, what we're using here is M equal to 1. So I need to write that down somewhere. Okay, and if you run that through your calculator, you get 1.065 minus 1, which sure enough gives me 0.065, which is 6.5%. And again, it's not a surprise because annually and the conversion period of yearly are the same thing. Okay, but what if instead the bank says, oh no, we're going to give you a quarterly rate? How would you compare that with an annual rate? So now we're going to use n equal to 4. We're still using the same rate of interest, but we want to know what the effective rate is. So that would be 1 plus the 0.065 divided by 4 to the 4 minus 1. And again, the reason you're subtracting off the 1 is because you have this 1 raised to the 4th power in there. And if you do this, this comes out to be 0.06666, or approximately 6.67%. So if I wanted to compare a quarterly rate with an annual rate, 6.5% quarterly would be the same thing as 6.67% annually. Let's go ahead and do one daily just to show you one of those. So M would be 365. Same thing again. The effective rate of interest in an annual setting would be 1 plus 0.065. But now we're going to divide it by 365. Raise it to the 365 minus 1. Running that through the calculator, we get 0.0672. There's more decimals out there, but we only need this. So that's 6.72%. So a daily rate of 6.5% corresponds to a yearly rate of 6.72%. So you can kind of see how the compounding period is working for you because these interest rates as an effective rate of interest are increasing and getting larger.